Hey, this is a preliminary review session for the flipped classroom AP Calculus for 2013-2014 that you should look at during the summer. Let's talk about how to write an equation for a line. If you're given the slope and a point on the line, just use the definition of slope. M, the slope, equals change in y over change in x. Or, in other words, y2 minus y1 over x2 minus x1. Define your given point as either x2, y2 or x1, y1. You can use either one. Example, let's say we have a point negative 1, 2, and the slope is negative 1/2. Set negative 1/2 equal to y minus 2, that's the y, divided by x minus a minus 1, which is plus 1. Just solve this equation for y, and we get what's called slope-intercept form. Y equals negative 1/2 plus x plus 3/2. Special cases. Horizontal lines, the slope is always 0, and so the equation would be y equals some constant c. Vertical lines, the slope is undefined, and the equation would be x equals some constant c. Parallel lines have the same slope as each other, but not the same y-intercept. Perpendicular lines have slopes that are negative reciprocals. For example, negative 1/5 and 5 would be two numbers that are negative reciprocals of one another. Basic functions and word problems. Okay, a lot of calculus involves some word problems, so let's see if we're on the same page regarding word problems. Express the radius of a sphere as a function of the surface area of the sphere. Okay, the first thing you would have to do then is find the formula for a surface area of a sphere. You could look that up anywhere. It's in your calculus book. It's also on the internet. Surface area equals 4 pi r squared. But they want that expressed, the radius expressed as a function of the surface area. That means we want to know what r equals in terms of SA. Solving this for r, we get r equals the square root of the total of the surface area divided by 4 pi. Symmetry to the y-axis. A function is symmetric to the y-axis if the graph of the function is a mirror image across the y-axis and it passes the algebraic test. This is not a negative sign but a bullet. We're saying that f of x has to equal the same value as f of negative x. Example of symmetry to the y-axis. Graph f of x equals x squared. Notice there's a mirror image across the y-axis. If I were to fold the paper on the y-axis, I would get the curve would overlay itself. I'd get a duplicate curve. Check algebraically by evaluating the following. Choose a value for x. Let's say 5. Evaluate f of x, and evaluate f of negative x. Well, let's see. F of 5 would be 5 squared, or 25. F of negative 5 would be negative 5 squared, or 25. Therefore, we would say this is an even function because the highest power of x is even. It's also symmetric to the y-axis. Symmetry to the x-axis. An equation is symmetric to the x-axis if its graph is a mirror image across the x-axis and f of x equals negative f of x. Okay, let's consider this. X equals y squared. Graph this equation. Notice it's a mirror image across the x-axis. For every x, there are two corresponding y values which are opposites of one another. Notice this is not a function, but it still is symmetric to the x-axis. It's not a function because it doesn't pass the vertical line rule. A function is symmetric to the origin if basically a rotation of 180 degrees around the origin leaves the graph unchanged. The algebraic test for this is f of x equals negative f of negative x. This is not a negative sign, but a bullet. Here's an example. F of x equals x cubed. Notice that if you graph this function and you rotate the graph 180 degrees, it looks the same. Let's check it algebraically. Choose a value for x. Let's say 3. F of 3 cubed is 27. Okay? Now let's check negative 3, the opposite of f of negative 3. Well, negative 3 cubed is negative 27. The opposite is 27. So 27 equals 27. Therefore, we would say x cubed is symmetric to the origin. Functions that are symmetric to the origin are said to be odd. And that's it.